This review covers Chapter 1 of the 2D course, and this chapter looks at lines and linear systems. So we're going to talk about the equations of a line, the different forms. We're going to look at how to put them on a graph, and we're going to talk about 3 different ways of solving a linear system. So most times you'll see the equation of a line in slope y-intercept form. This form is y equals mx plus b. In this form, m stands for the slope of the line, and b stands for the y-intercept. Those are the two numbers you're going to see in the equation. For example, y equals negative 3x plus 5 has a slope of negative 3 and a y-intercept of positive 5. When you're given an equation in slope y-intercept form and you want to put it on a graph, there's a general rule. And the general rule says begin at b, which is the y-intercept. So you start at the point where the line crosses the y-axis, and you move by m. And again, m is your slope. Now to move by the slope, we have to follow the rules rise over run. So when we look at our slope, we are going up or down by the rise. So whatever the numerator is of our slope, that's the number of units we're moving either up or down. And then we're moving over to the right by the denominator. That's your run. So in this case, we have an equation y equals negative 3x plus 5. The negative 3 slope is actually negative 3 over 1 because any number is the same as itself divided by 1. So when we're looking at this slope, it means we go down 3 and we go over to the right by 1 unit. When we're putting the line on the graph, we have to first start at the y-intercept. In this case, that's positive 5. So we're going to go and we're going to count up 5 units from the origin on the y-axis. 1, 2, 3, 4, 5, and we're going to put a dot. If we were to write the coordinates of this point, because it's the y-intercept, it would be 0, 5. So we start off at the y-intercept, and then we have to move by m. So we have to follow the slope in order to tell us how much we go up or down and over to the right. In this case, the slope is negative 3. So from this point 0, 5, I'm going to go down 3 units, 1, 2, 3, and I'm going to go over by 1 to put my next dot. Then from that spot, we keep going. We go down 3 over 1 for our next dot. Down 3 over 1, down 3 over 1, the whole way across the grid. When we get to the end, we might want to fill in the left-hand side of the y-axis, so we just go the opposite direction. We've already created our pattern, so we just go to do the opposite, up 3 over 1 to continue the line all the way to the extremities of the graph. Now, I don't necessarily have a ruler on here. I'm going to do the best I can. Make sure that you use a ruler to graph your straight line. I'm going to cheat a little bit. That's not too bad. And make sure when you graph your line that you label it with its equation. So y equals negative 3x plus 5 goes right up next to the line. Now let's look at an example with a fractional slope. Let's pick y equals, let's do 3 over 2x minus 4. So this line would begin at the y-intercept of negative 4. That means we go 4 down from the origin. 1, 2, 3, 4, and we put a dot. The coordinates of this point, again, would be 0, negative 4. And from that y-intercept, we are going to move by m. So we're going to go up 3. I go up because the 3 is positive. And we're going to go over to the right by 2. So up 3 over 2, up 3 over 2, up 3 over 2, up 3 over 2. And we can do the opposite to fill in the left side of the y-axis, down 3 over 2 to make our line. Now let's see how I do with this line over here. Oh, not too well. Okay, so one thing this app is missing is a ruler. So we label the line with this equation, y equals 3 halves x minus 4. Okay. So to graph a line, all you need to remember is to start at the y-intercept and then move up or down by the numerator of the slope and over to the right by the denominator. The thing is, not all equations will be given to you in slope y-intercept form. Some of them may be written in standard form. Standard form has all of its terms on one side of the equation and it equals 0. So ax plus by plus c equals 0. The numbers in this equation are your a, your b, and your c. C is called a constant term, because there's no variable next to it. And a is the coefficient of x, b is the coefficient of y. So an example of an equation in standard form would be 2x minus 3y plus 6 equals 0. That's an equation in standard form. Notice that all the terms are on one side and it equals 0. If we wanted to graph from standard form, we could do one of two things. So to graph, we could choose to rearrange, which means we would rearrange to y equals mx plus b, and we'll talk about how to do that in a moment. Or you could choose to use x and y intercepts. X and y intercepts. Okay, and those are the two ways of graphing from standard form. One of those ways isn't necessarily better than the other way. It just depends on the coefficients of x and y, whether it's going to be easiest to rearrange or easiest to use x and y intercepts. They both will work. So I'm going to move this down quickly. There we go. Now let's talk about how to rearrange first. In the equation 2x minus 3y plus 6 equals 0, if we want to rearrange the equation to get to y equals mx plus b, we're going to want to make sure that the y term is positive and alone. So let's put a note right over here. If you're going to rearrange, you make y positive and alone. In this example, the y is negative. It's negative 3y. There's a coefficient of negative 3. So if we wanted to take that and make it positive, we would want to move it over to the right-hand side of the equation. So we would have 2x plus 6 equals positive 3y. Remember, when you move it, it has to change signs, do the opposite. We used to be subtracting 3y. Now we're going to add 3y. So if we're going to want to make y alone, that means we have to get rid of the coefficient of 3. So we're going to divide every single term by 3. When you divide, it's going to make sure that the 3's cancel out and you're left with positive y all by itself, which is what we wanted in y equals mx plus b. Now we have to make sure that we reduce the fractions that are able to be reduced. 6 over 3 is not in lowest terms. 2 over 3 already is. So we can reduce the 6 over 3 to 2 over 1 when we rewrite the equation. So it becomes 2/3 x plus 2 equals y. Now that's the same thing as saying y equals 2/3 x plus 3. I know you're used to seeing the y on the left-hand side. It shouldn't make a difference where the y is, but if you want to rewrite it that way, if you find it's easier to graph that way, then you're more than welcome to do so. So if we wanted to graph this line, now it's easy to graph. We start at a positive 2 on the y-axis, which is right there, and we move up 2 over 3, up 2 over 3 across the graph, and we go backwards down 2 over 3 to get rid of, to complete the other part of the line. And again, that line would be a straight line with a ruler, unlike the one I'm about to draw, and it would have its equation labeled right next to it. Whether you write y equals 2/3 x plus 2, or whether you write 2x minus 3y plus 6 equals 0, does not matter at all. It's still the same line, just written in different forms. So one way to graph standard form is by rearranging. That's usually the way that we choose to do because it's kind of foolproof. Any equation can be rearranged to y equals mx plus b and is a little easier to graph. But sometimes we want to graph using intercepts because it makes it a little bit easier than rearranging. When you look at this exact equation in standard form, 2x minus 3y plus 6 equals 0, you can check to see if x and y intercepts would be appropriate as a method of graphing here. If the number that's all by itself, if the constant term can be divided evenly by the two coefficients, so 6 divided by 3 works out, and 6 divided by 2 also works, right? 2 and 3 both go into 6. If these two coefficients both go into the constant term, it's going to work out that your x and y intercepts are integers. They're not fractions, or they're not halfway across a grid point, so it would be easy to graph using x and y intercepts. If the equation were 2x minus 3y plus 5 equals 0, for example, 2 and 3 don't go into 5. Or if it was a 4, the 3 wouldn't go into 4, so that wouldn't be a good idea to graph using intercepts. In this case, though, it's okay to choose intercepts as a method of graphing because the x and the y intercepts are both going to be integers. We see, because we've already graphed the line, we can kind of cheat, that the y-intercept would be positive 2 and the x-intercept would be negative 3. So they're going to be easy to graph if we figured out the x and the y-intercepts. So let's do that. Let's graph using intercepts and see how it compares with our y equals mx plus b form of this equation. I'm just going to move the slide up a little bit. There we go. And we can figure out our x and y intercepts below. Now, this was rearranging. To graph using intercepts, all we have to do is for the x-intercept, we make y equals 0 in the equation, and for the y-intercept, we make x equals 0 in the equation. So our original equation was 2x minus 3y plus 6 equals 0. To find our x-intercept, we're just going to make y equals 0. So if we make y equals 0, that means that negative 3y would be equal to 0. We can really take a shortcut and just cross that out. So we're left with 2x plus 6 equals 0, which means that 2x is equal to negative 6, so x is equal to negative 3. That's our x-intercept, and that's actually what we see already on our graph up here. X is equal to negative 3. The coordinates of this x-intercept would be negative 3, 0. For the y-intercept, we can do the exact same thing, but this time we're going to make x equal 0. So 2x minus 3y plus 6 equals 0. If x is equal to 0, that means this whole thing is 0. So it disappears. We can take a shortcut again. We can just cross it out. That means we're left with negative 3y plus 6 equals 0. Now to solve for y, we want to make sure y is positive. So I'm going to move it over here. 6 is equal to 3y because I changed operations. It used to be subtracting 3. Now it goes over here and we're going to add 3. So if you divide by 3, that means y is equal to 2. I'll write it over here. Y is equal to 2. So that's the y-intercept, and that's what you see up here on the graph. If we were to label it, it would be 0, 2. So that's how you graph using intercepts. It's a little bit faster than rearranging the equation of a line, and there's less fractions, less reducing. But if it doesn't work out to be integer x and y intercepts, it's not the easiest method of solving. So I moved the information on lines out of the way because we're going to talk about linear systems now. A linear system is when you have two lines usually on a graph. There are two relationships that look at the same, that use the same variables, and they both are placed on a graph together to compare them. So either to look at, for example, cost versus usage, or looking at any type of x and y relationship to see which is the better choice in different circumstances. We could be using linear systems to talk about buying pencils and erasers. We could be using it to talk about distance and time if you're moving at certain speeds, to be talking about different television plans or different cell phone plans. They can be used to compare many different relationships involving the same variables. On a graph, a linear system usually looks like this. There are two, here are my axes, x and y. There are two lines, and generally, with linear systems, those lines are going to cross at one spot. It's possible to have those lines never ever cross if they are parallel. And remember, parallel lines have the same slope. But if the lines are not parallel, and if they're not equivalent equations, so basically one equation is a multiple of the other one, you multiply every term by 2, for example, double the whole equation, that would make the same line in the graph. They would never cross because it's the exact same line. You would have an infinite number of solutions in that case. But usually you're going to have one solution. There's two lines with different slopes that are going to cross at a certain point. And the solution of a linear system is called the POI, the point of intersection. And that's what you're trying to find when you solve a linear system. You're trying to find the coordinates of the point of intersection, this one spot where those two lines cross. So to solve a linear system, there are 3 different methods. You either solve graphically, so solve by graphing both of those lines. And we already did graph those lines in the previous section of this review, so we're not going to graph lines again. But when we solve graphically, what we want to do is we want to plot the lines, and we want to read the POI off the graph, and we want to write a conclusion. Therefore, the POI is, and that's it. Okay. When we're solving graphically, we're just basically looking at the two lines in the graph, finding the spot where they cross, and we're naming it as our point of intersection in a conclusion. The other 2 ways of solving are by substitution or by elimination. And those are the two algebraic methods of solving a linear system. So let's do a couple examples of each. We're going to look at how to solve by substitution and how to solve by elimination. It's really important for you to know, though, how to distinguish which method is going to be the most suitable method depending on what question you're given. So how do you know if you're supposed to solve algebraically using substitution versus elimination? Here are two examples of lines, or of systems, in fact, that we're going to be asking you to solve. First one, x equals negative 2y plus 3 and 2x plus 3y equals 1. That's the first system. And the second one, let's say negative 8x plus 6y equals 10 and 2x plus 2y equals 8. Those are two linear systems. If I ask you to solve them algebraically, you can choose whether to use substitution or elimination. How do you know which one to choose? What tells you, okay, I should use substitution for this question and elimination for another? Well, the biggest way that you can tell is you can look at the form of the equations that's given. If you look at this first equation, x equals negative 2y plus 3, you see that it starts with x equals. In a question, if you see an x equals or a y equals equation, that tells you want to use substitution. So you're going to choose to use substitution if it's an x equals or a y equals equation. There doesn't have to be two of them, just one is enough. So in this case, x equals and the rest of the equation, that tells you right away, okay, I'm going to use substitution for that question. You're going to choose to use elimination when both of them are in the same order. They're in the order x's plus y's equals the numbers. That tells you want to use elimination. Both of the x's line up, both of the y's line up, and both of the numbers, the constant terms, line up. So you can see, you can imagine yourself putting a line and a plus sign and adding those up, which is what we do in elimination. So we're going to choose to do substitution for the first example because it starts with x equals or y equals in one equation. And we're going to choose to use elimination for the second example because they're x plus y equals the numbers. They're in that order. So let's just move this up a little bit and we'll solve each question so we can see an example of each. The first one we're going to do by substitution. Now, when we're solving by substitution, we're going to start by numbering our equations. Number 1 and number 2. Then we're going to say, okay, which equation starts with x equals or y equals? In this case, it's equation number 1. So we're going to say, I'm replacing x with negative 2y plus 3. This equation says replace x with negative 2y plus 3 in the other equation. So I'm going to ask myself, where's the x in the second equation? Here it is right here. So I'm not going to write an x. Instead of that, I'm going to put what x is equal to. I'm going to replace x with negative 2y plus 3. I'm not going to replace the 2, so it still stays there. So I'm going to write down sub 1 into 2 because I'm going to use equation 1 and I'm going to put it into equation 2. And I'm going to copy out equation 2, except instead of the x, I'm going to put some brackets and I'm going to replace it with negative 2y plus 3. So 2, this used to be x, I'm going to leave it there, plus 3y equals 1. And instead of the x, I'm going to write what x is equal to, negative 2y plus 3. Once I've done my substitution step, then the hard part is over. All I have to do now is I have to use the distributive property to expand my brackets, and then I have to simplify my like terms. So negative 4y plus 6, remember it's a positive 3 times a positive 2 makes the positive 6 right there. Then we have the plus 3y that was already there equals 1. So my next step is to put my like terms together. I have negative 4y here and positive 3y over here. Negative 4 plus 3 is negative 1. Plus 6 equals 1. And now I want to solve for my y. I like to make my y's positive, so I'm going to choose to move mine over here to the right-hand side. And I'm going to move the 1 over with its constant term of 6. Those two are like terms, so they should go together. So I have 6, take away 1 is equal to positive y. When you move something to the other side, you have to do the opposite of what you were already doing. So my negative here, I was subtracting 1y. When it went over, it became positive 1y. I was adding 1 over here, it was a positive 1, so when it moved over, it became a negative 1. And I make sure to put what was already there first, and then what I move second. So 5 is equal to y, or y equals 5. It's the same thing. That's the y coordinate of my point of intersection. It's not the whole answer though. In order to find the x coordinate, I have to substitute y equals 5 into one of the equations. Now if I look up my original equations up here, the first equation starts with x equals, and since I'm trying to find x, that makes the most sense to substitute it into. It won't give you the wrong answer if you substitute it into equation 2, it'll just take you a lot longer to find it. So x is equal to negative 2, instead of y I'm going to write 5, because that's what y is equal to, plus 3. So negative 2 times 5 is negative 10, plus 3 is negative 7. I'm following BEDMAS when I work out my answer. So therefore, the POI is, I put the x coordinate first, so negative 7, and the y coordinate next, which is positive 5. So the POI of these two lines is negative 7, 5. Now let's take a look at the method of elimination. In the second question over here, we have x's, y's equal the numbers. We're going to have to eliminate either the x's or the y's. We can choose to do either. Sometimes we'll find that one variable is easier to eliminate. Now when we do elimination, when we get rid of one of the variables variables need the same number and opposite signs to eliminate. So in this case, if we were to eliminate the x's, we'd want to go negative 8x and positive 8x to make them cancel out. If we wanted to eliminate the y's, we'd have to make it positive 6 and negative 6y. How did I know to choose the 8 and the 6? Well, the number you want to get to is just the smallest number that both of the coefficients go into. So what's the smallest number that 8 and 2 go into? Well, both of them go into 8. What do 6 and 2 both go into? Well, the least common multiple is 6. The smallest number is 6 that they both go into. So depending on which variable you choose to eliminate, you might choose to make both of the x's equal to 8 or both of the y's equal to 6. When you make them equal to the coefficients, you have to make sure that the signs are opposite, that you have positive 8 and negative 8 or positive 6 and negative 6. Now, how do we change an equation? How do we make it equal to 8? This is a 2x right here. The way that we change the equations is we have to multiply them by something. So equation 1 and equation 2, I'm going to choose to eliminate the x's because I see that they already are opposite signs. This is already a negative and this is already a positive. So it's going to be a little less work for me to eliminate the x's than the y's. Always look at both options though to make sure that you can find the easiest route to getting to the answer. So if I choose to eliminate x, eliminate the x's, I'm going to make it negative 8x and positive 8x. That's what I want to get to. The way I'm going to do that is going to be multiplying equation 2 by 4. How come by 4? Well, because this 2 times 4 would give me negative 8. So I'm going to multiply the entire equation by 4. I'm going to write that in next to every single term so I don't forget. I can't just multiply the 2 by 4. I have to multiply this 2 by 4 and this 8 by 4 as well. Every single term has to be multiplied by 4 so I don't change the equation. So my answer is going to be 8x plus 8y equals 32. Now I didn't change the first equation at all, so I copied it as it was. Negative 8x plus 6y equals 10. Then I'm going to add the two equations together, because when we do elimination, we add those equations together. The 8x and the negative 8x are going to cancel. There's not going to be any x's left because they're equal in number and opposite in sign. So we're going to leave those. We're going to have 6 plus 8 is 14y equal to 42. So just dividing by 14 is going to give us the value of y. Y is equal to 3. That's the y coordinate of the point of intersection. If we want to find the x coordinate, we're going to substitute y equals 3 into one of the equations that we're given. Now if I'm looking to find x, and I'm looking at these two equations up here, This has a negative coefficient, so I'm probably going to choose equation 2 because it's a little simpler to find x in equation 2. So 2x plus 2y, well now I know y is equal to 3, is equal to 8. So 2x plus 6 is equal to 8. I'm going to move the 6 over. 8 take away the 6 is going to equal 2. So x is equal to 1. That's my x coordinate of the POI. So therefore the POI is 1, 3. Oops.